two major things. One is to review quickly the TableView components, how it works, and then take it one step further to show you how we can do updates and delete and add to a list, not to a list, to a table view. Okay, so let me run it first and then take it from there and explain further. So what I have here, I have a table view, and then in this table view, I have a toolbar with two buttons, update and delete. So when I select an element from the table, I can click delete and it disappears from the table. I can also click one of the elements of the table, click update, I show up a new form, change whatever I need to change, and then save it. Okay. And the add, I haven't completed the add, but the add and the update is exactly the same. The only difference with the add, we will give an empty form without any data in there. The user will type whatever they want. When they save, I will add the new item or the new student to the list, to the table, I mean. Okay. So let me show you how this is done programmatically. And next session, we will do one example end-to-end together from scratch without looking at any example. Okay, so let me show you the view first. This is the view, the table view, how it looks like. So as you see here, in this table view, the root pane, I am using a border pane. The top, on the top, I am putting a toolbar, and this toolbar has two buttons, the update button and the delete button. And between them, I just put a separator. It doesn't have any usefulness, just for aesthetic. Then on the bottom, I have an H box. And in the H box, I have a label. Yeah. Now in the middle part, what I have is a VBox, and inside the VBox, I have a table view. My focus is on this table view. So a table view, as you can see here, is made up of multiple columns. And later on, we will fill this table with some rows coming from student objects. So I have a list of students, and I want that list of students to appear in here, in this table. So what I do is, table is very easy to create. I can show you even quickly by deleting, come in here, I can look for table view, drag it to my VBox. Here is a table. It has two columns now. By default, I can go and change them. So for example, in here, I will give this one, this will become my ID column. In the code, I can give it a name as well, ID call, for example. Second column will be my first name column. And the name in code will be referred to as first name column or call, whatever you want to call it, just for to make it concise. So I have two columns here, and I can add more columns if I wish. You can see here there's a table column. All I do, drag it here, it gets added. I change the label of it, the text of the column. So this could be last name, and I give it an ID, an FX ID. I need to give it an ID because I need to configure these columns by code. That's why I give them an ID. And I can resize them the way I wish. So as you saw, it's very, very easy to visually build my table and my columns, okay? If I go to my controller tab here, what you can see is this view is linked with this controller, student table controller, and all the, it shows you here all the UI components that have a name. So every column I have named it. I have also named the table itself. I called it student table. And I have two buttons, update button and delete button. The reason why I named them, because I disable, for example, the delete button, update I haven't done it, the update button and delete should be disabled if nothing is selected. You see here, if I don't select anything, if I run this, and if nothing is selected, the delete is not is disabled. So the reason why I named this is because I will be accessing it programmatically. Otherwise, no need to name controls, as I explained last time. Okay, now that's it for the view. The view is very simple, but you can see here the view is not. It doesn't do anything interesting. It doesn't have any data yet. It's just empty. When I click the buttons, nothing is happening. So of course I need to write some code to make this more interesting, and to, when the form loads, I initialize the table and put in this case, the student list, and put it in the table view so it can be displayed. And then when the user clicks a particular student and click delete, I go ahead and delete the selected student, and so on. So this can only be achieved through code. That's it for the scene view. Scene builder, it just allows me to design the visual interface. And then I go to the controller to put the logic. So in the controller, which is called student table controller, I have this initialize method. If you recall, we have this initialize where we can initialize our components. In this case, all I am doing, I go to this class called the repository. The reason why I call it a repository, this is a good naming convention for classes that need to read and write from some file or database. So we call it student repository. Repository means it will be reading and writing to some file. Although I haven't done any files yet, everything is hard-coded here, but this can be easily replaced by reading from a file and then loading this from a file. Okay, so what you have here, I have a list of students. I add a couple of students to the list and then return the list. Now, as I explained before, I cannot just take this list as it is and pass it to the table view to display. I have to first convert it to an observable list. Remember the discussion, observable list? And what is the reason why I need to convert it to an observable list? Where typically the most common use case for Instagram, you have some celebrity, and they basically post images and videos and photos and maybe some text, maybe? Yeah. Yes, some messages. And then they have this celebrity, they have some fans that are following them. And then whenever there is a new update coming from the celebrity, all the fans will get notified and they can access these photos or video or a message that the celebrity kind of publishes. Okay, so what you have here, the celebrity, in our context, it's called observable. So the celebrity is an observable, and the fans are observer. Okay, so observable means they are pushing some events periodically pushing some events, and the observers listen to those events and maybe react to them. In this case, they might share those photos with their friend or whatever they need to do with those content that they get pushed to them. So that's the idea of observable and observer. So in this case, in our scenario, what is the observable? The list. So we have an observable. We have an observable list. That's why we don't use just a normal list. We don't use a normal list. We use an observable list. And in our case, what are the observers? Our UI components. It could be, for example, a combo box, a list view, or a table view. Table view. Yeah. So those are the observers, and this is the observable. So whenever there is any change here, these observers get notified and they update themselves. So if I have an observable list of students, I add a new student, that student will automatically appear in the table view. If I delete students from the observable list, automatically get deleted from the table view. This is very, very powerful in terms of UI development. We only, as developers, we only deal with the observable list, and the UI is auto-updated by itself, by JavaFX. Is clear? That's why we have the observable. And the analogy is this. We have a source called observable that pushes some updates or some changes, and we have some observers listening to those updates. Whenever there is a new update, it refreshes its view. That is why in JavaFX, I cannot just take a normal list and set it in the table view. I have to first convert it to an observable list and then set that observable list to the table view. Is clear? Yes, please. No, big difference. This is not really inheritance. This is maybe internally the observable list is inheriting from a list. Maybe. Yeah. No, it's not a difference. It's not a difference. Basically, this is taking advantage of a list. Sorry, taking advantage of inheritance to add more capabilities to the list. So a normal list is used for storage. We store values in a list. But an observable list, not only you store values, you can watch it and you can monitor it. If there is any change, you get notified and you can do some reaction to that change. So it is a list, you can still store values, but there is extra functionality. So it's not a difference, it's basically taking advantage of inheritance to extend the list with extra capabilities. To do before we are able to display the attributes of objects inside our table. Okay? So you see here, we have this table. How many columns we have? 4 columns, yes? ID, name, first name, last name, and email. And those will be linked with attributes of the object. You remember the student object, what attribute they have? ID, first name, last name, and email, yes? We need somehow to link the column in the table with an attribute in the class. Somehow we need to link the two, yeah? So to do this, JavaFX, Java people sometimes their choice of method names are not very intuitive. But we need to be patient. In here, this is how JavaFX allows us to link a column with an attribute. To say, okay, the ID column in the table is associated with the ID attribute of the object. Yeah? And the first name column is associated with the first name attribute, and so on. So to do this, I wish they gave us something as simple as something like set or link to, and just allow me to put the attribute name. Yeah? If I would design it, maybe I'll just keep it simple as this. But no. Being Java people, they said, okay, if you want to associate an attribute to a column, you go to the column name and you say set cell value factory, and you give it a new instance of property value factory ID. This one, just copy paste it and just do it the way they have designed it. Okay? It's just, what is the role of these 4 lines here?
To connect the columns with the attributes.
Yes, we need to do this. If we don't do it, you can see here, if I comment this out, I run my program, what happens is, I still have 4 rows. There are 4 rows here, or 3 rows, but there is no values. The table recognizes that there are 3 rows, but it could not retrieve the values from the attributes of the object. There is an object there, but the table is not able to visualize it. We need to give it a little bit of help to link the columns with the attributes. How do we give it this little bit of help? by setting this factory set cell value factory. Don't get these names to confuse you. This is the choice of the developers of JavaFX. Okay, they don't need to be perfect. They give us all this nice framework to build our UI. We need to be patient when they are making maybe suboptimal choice of names. Or there is more to it. I'm just simplifying it. The reason why here it sounds a little bit complicated, but the role of this line is just linking the column with the attribute.
That's why the name ID, for example, the first name has to be the same name as the attribute.
Yes, must be the same name as the attribute. Otherwise, it will not work. If I do here too, maybe I will even get an error. Let me see, depending how they have done it.
Well,
You see, it doesn't appear because it's not able to link the column with the attribute. So it doesn't fail, but it gives you won't see the ID. Yeah. So these lines are very important because they help us associate the column with the attribute. Yeah. And the way to do it is we have to follow the API or the methods that the JavaFX people provided to us, which is basically go into the column and say set value factory and give it a new instance of property value factory, and as this is creating a new object initialized, and we give it in the constructor we give the name of the attribute. Yeah, this is just copy paste and just change the names. If you don't do this, the data from the object will not be displayed properly on the table. Okay, is clear? Okay, now for delete, we have a delete handler. I explained it last time, very easy to do. All I do, I go to my table and I'll say get selection model, get selected item. Again, intuitively, somebody would have been easier to just say something like this, get selected item. But no, you have to go through get selection model, get selected item. Of course, the JavaFX people, they didn't make these choices just out of nothing. But for simple usage, they become a little bit verbose. You might find yourself, oh, why are we doing it this way? Sometimes you just take it as the surface value. This might make more sense if you go deeper. But at this level, there are little things that you need to be patient with. Some of the API are not as intuitive as it could have been. Is clear what I'm trying to say? Okay. So to get to the currently selected item, you have to go through get selection model and then get selected item. Once I get the selected item, what do I do with it? I go ahead and remove it. I remove it from where? From the observable list. Remember, student is, what is the data type of student? It's an observable list. Once I remove it from the observable list, what happened to it on the table view? Auto-removed. Okay? Because basically the table is linked with the observable list. Any changes to the observable list are notified, the table view get notified and the table view updates itself. And this is built in the table view. Is clear the idea? Okay. Now for the edit or for the update, I mean for updating a student, let me show you what's going on here. For update, I select a particular user here and I'll go for update. Okay. So what happens is when I click a particular student, I get the student object. I will create a new form or a new window, pass the student object to the new window. I display the information about the user, about the student, let the user update, and then they save back. Yeah? And for add, it's exactly the same thing. For add is also exactly the same thing. Okay? So here it is. Here is the example, update. So for example here, I update this, save, and it gets updated. Yeah. And for add, imagine add, when I click add, it will be an empty form. You fill it, you do save, it will be added to the list. I just didn't have a chance to finalize it. I worked This is what I could finish today, okay? All right, now, for me to really explain the forms, this is the last part, the most interesting part, the forms that you saw, something like this. The forms that you saw here, to do it in an elegant way, we have two concepts we need to understand, and these are the last concepts in this JavaFX. One concept is called properties, and the other concept is called binding. Properties and bindings. Okay, you need to understand these. Once you understand them, then you will be good to go with the realistic implementations. Okay, so let me try to give an example of what are properties and what is binding, and show you why they are so important if you want to build a successful user interface application. So let me exemplify this through Excel. Excel is a very excellent when it comes to properties and bindings to illustrate the concept. So what I have here, take a look at this. I have, for example, here 10, 20 equals just this one plus this cell plus this cell. Yes? Okay. Now, take a look at this. Every time I change this, what happened to the sum? It gets updated automatically, yeah, without any effort from my side. If I change this one, the results get updated. So in the UI, when we build the UI, in many cases, we want, if I change something in the UI, some other parts in the UI I want it to be changed. Because there are some dependencies between the UI components. So there is a dependency. So the value of this cell depends on these two other cells. Because it is dependent on these two other cells, I want this cell to auto-update whenever I change the other two cells. It is clear what the idea is? This is very common when you build a user interface. When you build a user interface, you basically have multiple components, and you want, if some component change, you want that change to be reflected in another component. And same thing for objects that are behind the visual components. If the object change, you want that change to be reflected in the UI. Similar to observable, we already seen this with observable list. Yeah, but observable list is just one example. Sometimes we might not be dealing with the list. For example, when I'm dealing with a student here, one particular student is not really a list. One particular student is an object, not a list. So observable list will not help me for one particular object. So we need something extra, and that something extra is what is known as properties and bindings, and that's what I'll be trying to explain. So this is very critical to understand. So first of all, are you convinced that the UI is made up of components, and these components could be dependent on each other? Which means if one component changes, that change should be propagated to other components. And same thing for the object behind my user interface. I want, if my user interface change, the changes the user makes in the user interface, I want them to be automatically propagated to the object. And if any change in the object, I want it to be automatically propagated to the UI. Okay? Here is my goal at the end of the day. Take a look. Here's my goal. At the end of the day, is my ultimate goal, and I will explain how this is done. My ultimate goal, here's my view, and here is my object behind the view. Can you see this? I have a view, and I have some objects behind it. What I want to do, if anything changes on the view, I want this to be reflected on the model. If any changes in the model, I want them to be reflected on the view, without too much effort from my side. That is my goal. And to achieve this goal, JavaFX introduced something called properties and bindings. Yeah. So let me now give you exactly what these are and explain them to you like gradually through some interesting examples that I have been working on. And you can see here as you drag this here, see as I drag it, this is a text box that gets changed, and this is a progress kind of a progress indicator. Progress indicator also get changed, and there's a label here get changed. Yeah. So what I mean here, there is a dependency between what and what? Yes, there is a dependency between the slider controller, the slider component, and the other UI component. Whenever the slider component change, that change gets propagated to the other components. Are you following? Yeah. So you can see here. Take a look at this. Now, it gets even more interesting. If you don't want to use the slider, I give you a text box. Now, if I type here 90, the changes in my text box get reflected on the slider and get reflected on the label and get reflected on the progress indicator.
So all of them are dependent on each other?
Yes, thank you very much. All of them, these ones, they don't have any control. They're just receivers because we cannot change them. They are not editable. So basically, they depend on the slider. Whenever the slider change, the slider notifies them, oh, by the way, I've changed it. It's time to change yourself, otherwise you'll be out of date. Yeah? But for this, for the text box, it's a mutual, it's a two-way dependency. So you see here, take a look. When I change this, it changes here in the text box. When I change the text box, it changes in the slider. In here, let me show you. So I want to illustrate this, that there are two ways of doing binding. There is one-way binding and there is two-way binding. Here it is. So between the slider and the label, and between the slider and the progress indicator, what type of binding we have? It's a one-way binding. It's also called unidirectional binding, one-way binding. What does that mean, one-way binding? Yes, changes on the source. Which is the source? The slider. Changes in the source are propagated to the destination or the observer. Which one is the observable? Which one is the observer?
Observable is the slider.
Yeah, this is the observable, the slider, and these are the observer. Okay. What I did to them, I bind them. I link them. Okay. If the slider change, I reflect that change on the label and the progress indicator. Yeah. Now, between the slider and the text box, what type of binding I have? It's a two-way binding. If I change the text box, it changes the slider. If I change the slider, it changes the text box. So this way is a two-way binding. Another name for it is bi-directional binding. Changes of the text box reflects on the changes of the text box reflects on the slider, and changes on the slider reflects on the text box. Yes, it's clear? So that's what binding is. So the binding allows me to create dependencies between components. Changes of one component gets reflected on another. Okay. Now let's see how this is done, and let's try to quickly do it together, but we have to be quick. Here it is. So let's see what we have. Okay, so what do I have here? This is a slider. By the way, I didn't show you this last time. It's very nice. You just tick this, and it gives you, if you tick these boxes, show tick marks and show tick labels. If I show tick marks, it always gives me these ticks on the slider. If I say tick labels, it gives me the actual values. In here, the value is from 0 to 100. The measure, what they call themselves? The measured tick units is 10. So it goes 0, 10, 20, up to 100. And The minor ones, I only want, sorry, 1 between them. So I can go 0, 5, 10. If I increase this, I will have 2 bits between each 2 numbers. You can see there I have 2. Yeah, but just keep it simple. That's it. This is the slider. Okay, the other one is text box. You know the text box very well. This is a new one, interesting one. It's called the progress indicator. Progress indicator. And this one is a label.